This is a schematic of a circuit board that controls the telescope mount, the Celestron CPC 800. It's with the GPS and having an issue with the amplitude coming from the, let's see if I can straighten the, interesting. So we're gonna, with the, get my throat cleared up here, get all set up, and that's interesting that this is not giving me a good, okay, there we go. Now it's correct with the, lined up with the microscope. Okay, so anyway, these two resistors are in line with the signals coming from two processors, and one thing I've had issues with is periodically the signal here where they connect together is the common I/O going to the interface to the hand controller and through the hand controller to the PC. And when I connect to a PC, the signal coming back from the controller, either one of these gets attenuated to the point where I lose mount control. So, but when I'm back on these areas, it's fine. And having had decades of experience with circuit design, I've never seen resistors this high in line with the signal. Typically, you see 1K or less. And so what I'm going to do today is actually reduce these to a 1K. And we're going to do that. So I'll move this off to the side and bring up the circuit board. See if we can brighten this up a little bit where it's a little bit easier to see. Okay, so those two resistors are R6 and R16. It looks like R16 and R17 on this board, but actually, if you go down to the bottom, this resistor is R7 and not R19. So it's R7, R19, R6, and R16, and you see where they're connected in common there to that point. And then they go off each one to two separate processors, one down here, U2, and one up here. And the top one is actually U7, the bottom one's U2. So, so what we're going to do is change out these two resistors. And we can zoom in there a little bit. There you can see 512, so that's 5.1 with 2 zeros. It's 5.1K is what those are. And I'll pause this and actually get set up to do some soldering. Okay. So we're going to remove those two resistors now. We use the hot air tool. Pull the glasses off and more. And one thing I'm going to be careful of is not to get the hot air too close to that connector down here or the ones up there. Luckily, these resistors are in the middle of the board where they're easy to get access to. And we can see that it's starting to have some effect on those. When you pull these loose, you have to have this setting on an insulated pad, which I have with the soldering iron. And by the way, I have my hot air tool set to 300 degrees Celsius. If you ever want to do this at And you're on. And there we go. Let that cool off. And looks like we didn't damage our connectors at all. Pause this again, and I'll go get replacement resistors to put in place there. Okay, I'm back now. One thing we need to do is clean up this area. I want to remove that solder and actually put some leaded solder. I know this is not the industry's way to do it now. They like to use lead-free stuff, but that stuff takes such a high temperature to melt, and it doesn't make that good of a connection, in my opinion. And it tends to grow whiskers. So there's a lot of negatives with the new technology that the old technologies just didn't experience, and the risk of lead poisoning is so low with leaded soldered. It's not near the, your leaded gasoline was the big culprit. I saw another video on that. I think it was Veritas that did a video on that leaded, and and it was the whole premise of the video was that lead is taboo and in all circles of life, and it's just there's more to it than that. He made a strong point in the gasoline market where you're burning the lead and it goes into the atmosphere and gets breathed. That's one thing, but with leaded solder, you're putting it on the board. It stays in solid form. It doesn't gas, and the amount that does go in the atmosphere is so minute that it has no effect on living organisms that I can tell. Uh, I've been using it all my life, and I'm still here, and I haven't become violent like the video claims. Anyway, we're going to do that. Now, another thing I want to point out about this board, one thing I did, a modification that I made. This originally came with a linear regulator, and I swapped that out. I'm cleaning it up here a little bit. It was a quick job that I did earlier, and I put these switch mode power converters on. And it's definitely necessary on this board because the electronics tends to take quite a bit of juice, and this will actually cut down on how much power you have to power this board with. And so if you're running on batteries, this will save your battery life if you're running your system on a battery, which is what I do at night when I'm out capturing images on the Celestron scope. Uh, okay, back to these resistors. What I want to do is clean this. I want to clean the solder off first. I put some flux down so we get good connectivity. I'll go ahead and turn my iron on. Let it warm up a little bit. Should come up and beep. See what temperature I have it set to. 200, 230. Yeah, I got to turn that up a little bit. Use a little Q-tip here to get some flux on there. And then we will use a solder wick to wick. Take a second here to turn the temperature up on this iron. Go up to 300. And that should be better. There we go. Okay. We've got a large oversized tip here, but for cleaning these off, this will work fine. quite as clean as I want, so I'm going to neaten up a little bit here. That will help. Feel the wick itself is getting pretty hot, so that's much better. There we go. Okay. I want to go ahead and change that tip out to a smaller tip. And we will, instead of cleaning that off, I'm going to add some more flux because we're actually going to go back and add some good solder to it. Changing these tips out is a pretty quick endeavor. There we go. Let that heat up a little bit, and while we're doing it, and the solder I'm using is Kester. It's a good old fashioned stuff from way back. It's cheap. And I'm using Pro Wick solder wick. And the iron is definitely ready. This is a much better size. And I'm going to go ahead and solder everything. And you're probably thinking, how's he going to get the resistors on that without the big bulge of solder? Yeah, well, that's where the hot air tool comes in. I usually tack one side down and then I go back and reflow everything with the hot air tool. There we go. Now we go back over that. It shouldn't take, with the leaded solder, this won't take near as long. It'll heat up and melt pretty readily and quick. There we go. That takes care of that. And it's just a matter of doing a cleanup using the denatured alcohol, if we have any left here. The bottle has some in it. Doesn't want to pump to the top. Probably not enough alcohol in the thing. So we'll just call it quits, but basically we just clean up with a Q-tip and we'll be done. And we'll next clip I'll show you what the signal looks like.